Okay, so if we just start question 1, page 1, let's go. My solution's probably slightly different to yours, so let me know if there's a huge discrepancy as we go through. Didn't bring my glasses, lots of glare. Okay, so I'm going to be talking about, I guess, what I've seen last year when I was marking. So I guess keeping in mind, I'm not sure how many students in total do essential maths across the Northern Territory and South Australia. I see about 170-ish exams. So this is based off, I guess, that particular sample. So I guess starting just with the measurement topic. I think one thing that I find about the essential maths exam is that for some of the students I've taught, the wording of the question can be really quite challenging. So the diagram for this one I thought was really good. I guess I can talk about what we were looking for. I can't necessarily talk specifically about the marks allocated. So for the first one there, just looking for the perimeter of the star. So 16 times 6 equals 96 was basically how most students did that. 6 plus 6 plus 6 plus 6 continuously was not uncommon and gets you the answer, so that's completely fine. And then the area of the star pattern. So the area of one rhombus was generally found first, and that multiplied by 8 was done pretty well, so that was pretty good. Show questions, I think students, sorry, I'm just going to take this out because I can't see my page. Show questions, I think it's important that we let our students know that they really need to show the calculation that they're doing for that. The final answer is not necessarily the most important part of that. So 20.5 times 20.5, giving an answer of 420.25, not necessarily important that they show the 420.25, but that calculation beforehand really is the most important part for the marks for that particular question. This is probably not going to be efficient as we go through. Yell out if you've got any questions or queries as we go. Otherwise, we'll be just listening to me. Then if we're talking about calculating the area. Yes?
Just thought I'd ask one, Lavender. If a student wrote 420.25, sorry, if they didn't write that and they just went 20.5 times 20.5 is 420, they still get them the mark?
Yeah, yeah, yeah. So realistically, we're looking for the calculation for that one. Yeah. The money shot is 20.5 times 20.5. Yeah. So the area not required, really important, I think, that the follow-through question. So really encouraging students to use what they found previously and keep working with it. I think what I've noticed is that students who keep answering questions, even if maybe they haven't got the right values that they're working with, they tend to still pick up, a large number of marks just by showing method. So I've tried to identify it as we go through the follow-through each time. So if I don't mention it, yell out. Yeah.
I was just curious in terms of penalties for units, if they continuously didn't, or what's the protocol with units missing?
Yeah. Okay. I'm not sure how much I'm allowed to say, but is this being filmed or is this being shown? So the area not required, whatever they found previously, so hopefully it's the 40.25 minus the 203.52. They could use the 420, it didn't have to be exact, but just indicating that they know that they are making a subtraction there. And I guess the official answer that I've come up with is 216.73. But yeah, that follow through is super important, that we encourage our students to just keep having a crack.
And if they couldn't work out part C there, are they allowed to say, assume 400?
Yeah.
Lines or
420, yeah.
So they can make any assumption they like on question.
I think so long as they are using the values in the right spot. So that particular question requires the answer from B and the answer from C part 1.
So if they couldn't work out, they would have said assume B is 200 and take
I think they'd have to have a calculation for B. So the follow through would be if they've got an answer that they're running with and they use that the right way moving forward, then that would be, that's my interpretation, I should say. The 9 panels would be that 420.25 or 420 times 9, and then the conversion. I always worried a little bit when I see conversions on exams because I think, I don't know how my students would go with that. I think surprisingly well. So whether they showed the actual conversion calculation or not, overwhelming number of students that I saw got that conversion correct. So, high five to them. That's awesome. They did need to show the converted value for that. So not necessarily working out, but definitely the value that was correct. And then part E, I think was probably one that was really quite challenging. I think I saw maybe a handful of students get probably the full marks for that one. So we are looking at so the quilt has to be at least 4 square metres. So we are looking at a 2 metre by 2 metre quilt. So number of ways that you could go about looking at that. So if we divide the 200 centimetres across by the 20.5 that we found for each panel, we end up with 9.75 squares. So that's looking at a square quilt. So we needed a 10 by 10. So we needed 100 squares for that one. A couple of other different ways that they could show that, but they needed to recognise that it was going to be a square quilt, and so square dimensions were required. Few reasonable attempts, so different ways of calculating it, but a lot of students came up with like the 9.75 and said, oh, well, 10 squares. So I guess, yeah, an understanding maybe of the question perhaps, but definitely a lot of attempts, which I think, if you see an attempt, I think that's, always better than a blank space, so you never know. Any questions overall about question 1? So question 2, so an island, patrol dogs on an island protecting penguins, awesome. So we've got the diagram. I like the diagram. I think that students I was teaching probably were okay with that. Again, a show question for that question A part 1 needed to show the method for that one. So Pythagoras 1 squared minus 0.8 squared under a square root sign would give us 0.6 kilometres, ideally. If they added, that was an error, and so indicating that they were finding that short side was important. Calculating the area of the triangle for DEF, and again, follow through opportunity for that one. So whatever they found to be their answer for part 1, if they used it correctly in part 2, and we were looking for 0.24 kilometres squared for that one. Done really quite well, I thought. And I think the next part, so they had to label, and so pretty much what we're looking at for this was students either did it and they got it right, or they didn't do it at all. And I think the overwhelming number of attempts that I saw, they got it right. So fussy about where it was placed, no, not really, but if it was on the right side and the right angle, that's really good. You can identify that they know what they're talking about. I kind of worried to start off with, that looks a little bit tucked away, whether or not they would have noticed that question, but overall, most students that I saw absolutely got it right. Then again, showing for that second part there, sine rule. So a common error for it was that students were using the cosine rule and making the assumption that FG was 1 because it looked kind of similar to EF. And that was deemed to be an error for that one. We were looking for the sine rule, so I'm always drilling into my students that we want ideally we want the formula, substitute into the formula, rearrange it, so important that they can rearrange and find the right answer for that one. Not necessarily starting from scratch. I think you could start with the rearranged version of the formula and put the values in, but given it's a show question, just important that they show the method that they've used to get their answer. And again, part 3, show. So they've given the formula. I know I've spoken to a few teachers who teach the subject, and they were kind of thinking, I'm not really confident that my students would be able to do that. Again, I'm not sure if we should be surprised or not if our students are just awesome. Overwhelmingly, they got that done quite well. So 0.35 kilometres squared for that. So yeah, if attempted, generally done really quite well. And then that last, I shouldn't say last part, part C, follow through opportunities. So we were looking for the total area of the island. So thinking about any errors for area that we might have found earlier. just using those correctly to find the overall area. We're looking for 1.34 kilometres squared, but whatever worked with the values that they had. So, there's a lot of flicking backwards and forwards as a marker sometimes to figure out where they're getting their answers from, but if they're from the right spots, perfect, they get the marks for those. And then for the Simpsons rule questions, so part D, let me know if I'm going too fast or if I'm just monologuing and talking to myself. So I think previously when I've marked, I've gotten to the Simpsons rule question. I've always thought, wow, that's really great, really easy marks for them. They follow the process. Not so much this year or last year. Finding that the width was 0.8 seemed to be really confusing for students. So that seemed to be quite a common error. And again, I'm just talking about what I saw. The other error seemed to be perhaps confusion over the end. So 0 and 0 on each end. So there was pattern errors. Instead of having the 0 plus the 4 times, then the 2 times, the 4 times, and then the 0 on the end. Fairly common to see a 4-2 without, 4-2 and then forgetting that last 4, or 1-4-1 instead of what we should have seen. So looking for a roundabout 3.49 kilometres squared. But yeah, that width calculation seemed to be quite confusing. And I've just done it recently with my current Year 12s, and they can do it fairly easily when they're given the width, but if they're just given the total length, they kind of freak out a bit and things go broken. So yeah, I was surprised. I thought, Simpsons rule, amazing, easy marks.
Did they divide by something different, or they just left it?
So 3.2. 3.2 divided by 3 was fairly common. I think that was probably, they got it, or it was 3.2 divided by 3, 1.56, so that first length divided by 3. Then some fairly random things as well that I'll never know where they came from, but yeah. I think I quite like diagrams for question 2. I thought they were, whether the kids cared that it was about patrol dogs on an island looking after penguins, the diagrams I think were really helpful. And I think if I think of the students that I had last year, the diagram, a picture for them is always really beneficial. Question 3 with the fountain. Did I finish that one off? Sorry, I don't think I said the bit about the additional land at the bottom. And there is follow through for that one as well. Whatever they got for the Simpsons rule calculation, minus whatever they calculated in that previous part C, follow through for that. So ideally 2.14-ish, but follow through awarded absolutely for that. Question 3, so we've got our volume held in the cube. So we are looking for a 3 by 3 by 3, so 27 metres cubed for that one. I don't know about you, but my students, radius, diameter, which one's which. So I was pretty happy when most students got 1.5 divided by 2. That was really good. Then given the formula and substituting in, so the follow through, if they had the wrong value for the radius but used it correctly, awesome. Full marks for the next part. And a common error for this was finding the volume for 1/4, so dividing by 4 in the end. And I guess I can kind of see how that makes sense because the picture at the top is for 1/4, and so I'm just trying to get inside my students' heads. Then finding the total volume of the water in the fountain. So again, follow through for those. Just adding the volume of the cube with the volume of the sphere that they found previously for that one. So then the litres pumped for that one, fairly straightforward calculation. So they're just doing the litres per hour times 60. So pretty good responses from students for that one. So the 5130 litres per hour. And then the number of litres of water in the fountain. So the conversion to litres was done really well. So again, I sort of cringed a little bit and wondered how my students might go with that. But again, overall, pretty great. Kilolitres was also fairly common, and that was fine as well. So still a conversion for that one. and then how many hours it would take for all the water to be pumped out of the fountain. So using that 38,500 litres and dividing it by the litres per hour, about 7.5 hours, but the follow through was there as well. So if they had a different answer for the litres in the fountain and the litres pumped, then they used that correctly. And then another common method, I guess I'm not going to say error, but method was to use the volume that they found earlier in a part 4, convert that to litres, extra work for themselves, but still did it right. And they ended up with 8 hours for that as well. So I guess, not incorrect, just interpreting what's going on slightly differently. And then stating one assumption. And so I guess what I try to explain to my students is that you want to state the assumption, you don't want to rant and then contradict yourself in that rant. So just stating what you need to and then moving on. Some assumptions that we had were all water can be pumped out, pump continues without intervention, continues pumping at a constant rate. One student mentioned it doesn't rain, so yeah, that makes sense. And the pump's not turned off. And I guess, just making sure that they don't contradict themselves. As soon as they contradict themselves, they lose the mark that they might have had. So state the question, move on. Don't over-explain. So that was the end of the measurement. How are we going for time? Am I going slow? How much time do we have? What time do we finish? Oh, how far to go? Okay. I would say as a marker, the statistics part, my least favourite part, and if I survey my students, also their least favourite as well. Really wordy. So when I first saw this, I was, that's a lot of words to go through. And I think as well, do students understand what's going on with that particular concept as well? This is my opinion, no one else's. So first off, discuss the reasonableness of the statement made by the owner of the travel agency referring to the survey method. So important that it needed to refer to the method and not the sample size. Some suggested answers that we had was only surveyed those who booked travel, only received responses from half those surveyed, and convey that this is biased. So in some way, if they could do that reasonably and clearly, then the marks were awarded. For a discussion, it sort of needs to state what they're going to talk about and the impact of that as well. And I guess anything that's reasonable, anything that makes sense, students can give them marks for that. State one, so then we've got the fact they're going to change the survey method and we want one advantage of it. So increased sample size was one, less biased. I guess we were mindful of the fact that students could repeat themselves or contradict themselves as well. So just, I guess, every year I try and think, how am I going to get my students to answer those questions a bit more clearly or a bit more concisely? I haven't found the answer to that yet. But my students do tend to contradict themselves in the next part of a question. So if you figure out how to fix that, please let me know. But it was generally, I guess, that and the next part, state one disadvantage of the method. So it was time, money, responsive error we accepted, or anything else that made sense for the context of it. Both 1 and 2 were done fairly well. So I would say the majority of students got the marks for those just as making a statement. And then state what type of survey is being used if the staff would collect responses from every resident. I guess the official answer would be a census, but population was okay as well. In fact, probably overwhelmingly students answered with population for that one. So we accepted that one. Then looking at a stratified sample, and again, I probably look at this and I think, stratified sample, it's a fairly routine process. My students should be able to do that fairly well. This was actually done quite poorly from the exams that I saw. Just calculating the 680 over 17,000 times 500 to get the 20 people. I couldn't even find a pattern in what students were doing that was fairly all over the shop with what their method was. Students who I would probably say, I don't know, maybe 20% of students whose exam I saw got that correct. There was some, I guess, attempts that kind of looked like they were heading maybe on the right track, but for 1 mark, you know, it needed to be right, I should say. It doesn't kind of need to be right, it needs to be right. And then for that second part, if we've got 40 people in the sample, we needed to go back and calculate the total number of people in the age group in the town. I've got to be honest, I'd never done that with my students before, so working backwards. A lot of students could see that, well, 40 is 2 lots of 20, so they doubled what they got previously. So the 680, now we're looking at 1360. And a few students kind of had the right idea about how they wanted to put the values into the original formula, but then they couldn't really work too far from there. So that rearranging, again, I find difficult with my students. They struggle with that. That was difficult. And frequently this question was not actually attempted, so they moved on from that one. I kind of wonder if perhaps the question overall just wasn't understood by students. Any questions about that one? That's my least favourite question, I think. Blank page. Question 5. Whilst as a marker, I thought this was great because it was really quite quick and easy to see where the answers were. I do worry that for students it was maybe a little bit limiting. I'm not sure if I'm allowed to say that, but I thought it was limiting. So putting their answers, the data into the stem and leaf plot, ordered, overwhelmingly done correctly, maybe one out of place somewhere, but we all do that. Then for part B, right or wrong, and so I feel like that's a little bit limiting for 3 marks. So we're looking for less in part 1, larger in part 2, and boomers in part 3. If part 1 was incorrect, it was common for part 2 to also be incorrect as well. And part 3 was generally correct. So like I said, great question as a marker because you can see really quickly what's going on, but I do think that perhaps for students, not so nice.
Yes. Would you award any mark for if the error was carried forward from the previous question?
Yeah, for that one. Yep, so if they had their, it was uncommon for it to be, I guess, so significant that it would change those answers, but absolutely, yeah. Then for stating the outlier, so a common mistake was to read that outlier as 79, and that was considered an error. So I guess looking for that understanding of what the stem and the leaf means. But if they had filled in their stem and leaf plot incorrectly and they had a different outlier, then that was awarded for that. So I guess as markers, we're looking to give the students marks wherever there is opportunity to do that. Part 2, the only option students had was to mention the median and the fact that this was not affected by outliers. And I would say that very few of the exams I marked had that answer. So, and you know, I think those questions are probably really difficult for students to answer as well. Then for the table, the minimum and the maximum were done really well. If there was an error, it was generally with the mean and the median, so calculator skills perhaps for that one.
Was there any penalty if they didn't go to 1 decimal place?
No. Yeah, 2 decimal places, 7 decimal places, yeah. We take all sorts. And I think, you know, some students are really confident with their rounding and others aren't so much. So yeah, if it appeared on the calculator screen, sweet, we'll take it. My students hate drawing box and whisker plots. I do too, to be fair. But follow through based on whatever was in that table moved over to the box and whisker plot. So this one probably, I think, as a marker, this took the most time to mark. So we were looking for the fact that students could use the scale. So the approximate shape was correct. If it was you know, the median 69 for Gen Z, if it was just before the 70 or pretty close to the 70, sweet, we'll take it. The outlier wasn't really indicated well. There was a bit of discussion, I know, around, you know, was the outlier removed, was it not removed? So we tried to mark according to the understanding of the student about what to do with the outlier. Needed labels. So, I mean, I tell my students, please use a ruler, and that would be lovely. But I guess approximate shape, size, labels, and we're pretty happy with that. And like I said, follow through from that previous table. Then part F, or question F, students could really tick either box so long as their explanation matched and supported what they ticked. So we sort of considered that there wasn't necessarily a correct answer for that as such. It was more about how students answered. So you could say that the 10 to 17 age group had less money to spend, or they might buy more snacks, or they might not buy, more likely to buy snacks rather than meals. Or 42 to 49-year-olds might be more money conscious and so might spend less money. However students worded it, if it made sense and matched the box that they ticked, then we were pretty happy that they understood what was going on. Oh, almost through the stats. So question 6. I think when I saw the table originally, I thought, oh, that calendar number of years since 1900, will that confuse students? I would say no. They seem to cope with that quite well. So the dependent variable was temperature, and most students could answer that correctly, so that's awesome. We were looking for increases for part B, and to calculate the coefficient of determination, most students could get the value, so roughly 0.876. And I'm not sure if you have so many decimal places on your answer, but we sort of give a few so that we can check rounding or, you know, see what they came up with. So we accepted strong or very strong for that one, but we did not accept moderate. I guess I'm not sure how many students put the brackets on their note pages when they go in. Yep.
Your solution states positively. Do they need to say?
Didn't say positively, no. So we're just looking for the R squared value, strong or very strong. Yeah, no problem. I think that one was done quite well. I'm trying to think where. I didn't have a note on that one. I'll assume it was. Then I think, if I think back the last few years, they've had to come up with the equation, the least squares regression equation themselves. And so I sort of wondered, is it a huge benefit to them that they get given that? And will they know what to do with it? Overall, the part D was not done well from what I saw. So you're substituting in 125 to get 14.34 degrees. I guess overall not done well, but in a lot of cases not attempted. So I sort of wonder if maybe by giving them the equation, stats I think is very like we do this and then we do this and then we do this and we have this equation. Maybe giving them the equation kind of within all those words at the top perhaps was a bit distracting maybe for students, or they weren't aware of it. So I was probably a bit surprised by that. I was sure that that would be beneficial and, you know, fairly easy to do. Then the next part, calculating the new coefficient of determination, I can't talk, with the extra 2 points included. 0.919 or 0.2, somewhere around that. In most cases, we got values nowhere close to that, or just not attempted at all. So I'm not sure if the extra data was confusing to students, or maybe I kind of think if students didn't do so well in part D, then it sort of showed a bit further on in part E as well. So perhaps the question overall just was not friendly. And then the next part, discuss whether the new equation of the least squares regression line, including the 2 extra data points, would be expected to give a better prediction. So we checked E part 1 to see what they had. Assuming they had the answer, and we were thinking there was a stronger relationship, so we could mention that. We were looking for the word extrapolation, and so few students use that word specifically. I found that sort of a little bit surprising, because I know we sort of like hammer those words into them: extrapolation, interpolation. So yeah, I guess making sure that they use those keywords within their solutions when they are talking about making predictions from their least squares regression line. Any questions overall about the stats part? No? Just check. Okay.
Sure. Wording that last bit. You say in both cases it's outside the data set. So that's not enough. They do need to use the word.
Well, yeah, the word extrapolation was key. Just reading my note to myself for this one. So finance. So I think if I look at how students answer their questions, and probably you can really tell when students are really confident with the finance section, because they've got all their calculator inputs. They've got, you know, their little summaries at the end about what they found, and you can tell that finance is their thing. Excuse me. Putting all their calculator inputs was really important, and I think that you know, having that process of putting them down for each question. I know some students find it easier just to put down what's changed, but as a marker, it sort of helps just kind of show what's happening if they have all of them. We're treasure hunters, we can find anything, but that makes it easier. And showing the negative for part A was really important. So we were looking for the negative sign. I'm just going to double check that I have the same values here. For that one, yep, so showing that it's about 1,270, so 1,267.96 roughly with rounding. For that one...
Sorry, can you just go back to that negative? I missed what you said there.
You're saying
You
that
wanted
it
that
has to be
in the
negative.
calculation, or?
They have put it in there.
Oh, I do apologise, then negative. We
Well,
were looking
good.
for a negative.
Yeah.
So I had it on the PV for that one. Sorry, I missed that when I checked the solutions.
So the
I
Yeah, I
use a
just
different
have
process.
Yeah?
I
you should
always
put money in there.
PV is positive, FV is always negative,
Yeah,
and
yeah.
your
So,
payment changes positive or negative.
yeah, so, and so long as there's a negative in there to indicate it.
But then in that case, the solution, if they just wrote the answer, you still want them to say that it was a negative
Yeah,
PMT,
yeah, so looking for
and then write the answer.
Yeah, yeah. And I think you could just give the negative in the PMT, just showing that you've got that negative
Yeah.
value somewhere.
Yeah.
Yeah. And I feel like maybe that was a bit newer to me. Again, follow through. There's lots of follow through for the finance. So students could use the 1,270 for the next part, or they could use the value that they got, assuming it was close to that. And this time we're looking for the future value, and again, looking for a negative in there somewhere. For that one, I had it on the PV. You might have it somewhere different. And so if they use the 1,270, I think you've got the both values there as well on there, so that's great. And then the next part, so showing that Jai is going to have approximately $39,900 in his account, so subtracting the values that we've got there. Yep.
With question 7A, do you get many kids trying to reverse engineer it and get the time? And stuff like that?
Yeah, and we do accept that. So if they've shown how they, their inputs and it's come out the same, yeah, absolutely. Yep.
Can I ask for part B, if they haven't shown an IPV, PMT, blah, 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 but they get the right answer, is that too much?
Yeah, no, so if they have the inputs that they've changed, yeah, and they've got the, yeah, absolutely, yep. Like I said, from a marker's point of view, really easy to know what they've done if they
they've
show the
done the
inputs,
work,
but
they just
yeah,
haven't,
for sure.
Any other questions about that one?
So for B, if they just wrote down the answer with no calculating inputs,
They should get the answer for that one, because their answer would indicate their negative for that. Yeah, for sure. Any other questions? I feel like finance is probably the one with the most intricacies for it. And yeah, follow through. So Again, a show question. So I guess for the questions in finance specifically, when they say show, you'd probably want the calculator inputs, absolutely. The ones that don't say show, less so. So I guess it's showing that method that they've used. Looking to end up with 32.97 months for that one. Again, showing where a negative goes for that one with their inputs. And again, you could use the $1,270 and the $39,900. So I guess a variety of different combinations for that was used, and we accepted all answers. Then show how much less. So this one's now, I guess, a bit more of a two-part situation. So calculating the new PMT value, follow through. So again, range. This is the part where markers end up sitting on their calculators for a fair bit of time just checking. And then the part that's, I think, maybe forgotten or not considered is the less, I guess, how much less. So calculating the, I guess I've used the $1,267.96 minus that PMT value that we've just found. So that second step there was, I'm not going to say a lot of the time, but frequently, I guess, or commonly missed. All good so far. So that's the end of question 7. Amazing. Then question 8. And I saw the table. I started to panic. I thought my students would never be able to interpret that. That's a lot of information. That part A done surprisingly well, like overwhelmingly got correct for that one. So that's awesome. For part B, show that Sam has 8 years to reach his goal. 65 minus 57 is good. A lot of students wrote 8, but again, having to show that method. So I sometimes wonder if it's so straightforward, they worry that it's so straightforward it must be wrong. Yeah, simple, confusing. Again, having to show the method, but just writing 8 because perhaps that was so straightforward it seemed ridiculous. Again, show for part 2 of that. Indicating a negative is used, or having an answer that indicates that a negative is used. Not for that one. You have to show the negative. It's a show question. And finding a PMT value for that one as well. And again, if there's more than one way to do it, so that reverse engineering process, and they've indicated values that are pretty close to what we started with, then that's completely fine as well. Again, sitting on the calculator, trying to figure out what they've done as well. State one assumption. So again, stating that one assumption, not explaining it or going over the top and then contradicting themselves. So we had no fees, no money added or withdrawn, a constant interest rate, or the fact that I think is it up to Sam at this point? Sam stays single was also fairly common. Some comment about employer contributions remaining the same, or related to the job being consistent, pay being consistent, or the effect of inflation as well was considered as well. Then for part C, show again the amount that Sam would need. So for this one, we were looking for it's an inflation calculation. I tend to just tell my students to do what it is times 1 plus the interest rate to the power of how many years it is. But quite commonly it was done in the TVM solver with the inputs for it. Both were done quite well. Some students did it both ways, so awesome. And yeah, both were accepted either way. Then how much longer it was going to be. So again, I guess that 2-part to the question of using TVM solver, we're looking for roughly 40.23 quarters for that one, and then the additional time being the 40.23 minus the 8 years worth of quarters. So we ended up with 8.23 and various values of various, I guess, ranges of that depending on whether or not the 1650 was used, the 1,648.09, whatever version or combination was used, we accepted those as well. And then with a promotion and a higher salary, so one effect that may have on Sam's retirement, so more money at retirement was pretty common, or the fact that he could retire earlier, and that was answered quite well. I thought their understanding of what was going on there was really quite clear, which is great. the last question? Yes, almost done. Okay, question 9, smash it. All right, so again, putting in inputs for this one, we were looking for the future value, so nice clear inputs for that is great, or an answer of $913. The interest for this one, so looking for $3 for that. Follow through, absolutely given. Again, whether or not this one was so straightforward that students got confused by it, but there was some quite elaborate things happening for that. It was quite rare to see the answer of $3 in the end with what they were doing. Sorry?
The I is 1.57 and 1.37. Is that a typo? 9.8?
See, they've just did a transcription.
Is that, yeah? Sorry, like I said, mine is slightly different to yours.
They just
Yeah? Oh, yeah, yeah.
Here, they put 1.57 and it should be 1.37.
Yeah. Part A, yeah. So then calculating an interest rate, so simple interest. This was not done overly well. Students who used their calculators for that part tended to make the error. So they had their interest as being the $1,020, not the $20. We were looking for an interest rate of 4%. If they just used the formula for that, that was done quite well. But then, yeah, I think my students are either incredibly confident with the calculator for simple interest or they just cannot. So I tend to encourage the formula for them to use that. I'm not sure if anyone has any similar experiences, but I just get quite frustrated with them doing simple interest on the calculator. Follow through for part 2. So just adding the 913 with the 1,020. Calculating the interest rate required for that, so inputs for that one, or the answer of 3.87 roughly. And then the next part was sort of read together. So one assumption made in part D, and there was quite a variety of different statements that were made, and a lot of them were really good. So the payments are consistent, there's no withdrawals, the rate's constant, there's no fees or charges, and probably one that made us as markers all think was the interest rate is available. So you can go into a bank and say, hey, I need that interest rate, and I thought that was that showed a fair bit of understanding about how the world works. And then quite common for students to mention inflation, and that was considered not an acceptable answer for that one. We did try to read part 2 and the next part together, and so I guess marks were sort of awarded between the two, and explain the impact on the length of time it would take SANZA to have $20,000 in saving if the assumption in D part 2 changed. So the impact needs to be linked to the assumption, and so there's a variety of different things that they could say for that. And then also students, tend to get to the next part and then they reset about what they were saying. So if they could state another assumption and explain that well, then we sort of figured that, well, that's okay. They've kind of done the job. They've just done extra work as far as working between those two sections go. And I think that's the end. Does anyone have any questions? I feel like bland way to spend the afternoon. Thanks for listening to me ramble on.